All right, we got to get through front, back, which is a lot of stuff you already know. And then the next front, we're going to do the evens, and we'll save the odds for tomorrow. Okay? Yeah, ready to roll? You should know how to do quite a bit of this. For number 1, we're taking the square root of 52, x to the 6th, y to the 5th. How could I start number 1? Yeah, find the factors of 52. What am I looking for? A perfect square. So 1 and 52, 2 and 26. Oh, 26. Not 3. 4 and 13. 13's prime. Even though 4 is on the left side, 13's prime, so that's the one that we want to go with. So we can say, okay, this is really the square root of 4 times 13 times, if we're square rooting, we want to find squares. What could I square that could give me x to the 6th? X to the 3rd, good. And then what could I square to get y to the 5th? Y squared. That'll get me y to the 4th, so I need one more y, so times y. I know the square root of 4 is 2. And then here, where we have x to the 3rd being squared, that's going to come out as an x to the 3rd, but it does need to be absolute value of x to the 3rd. That's because if you plug in a -1 to x to the 3rd, -1 to the 3rd power is -1, and that can't happen with square roots. So absolute value around x to the 3rd. Am I going to need absolute value around y to the 2nd? No, because anything to an even power is going to come out positive. So we don't need absolute value around y to the 2nd. What's underneath my square root? 13y. As of right now, I do not have any quizzes or tests down for this week or Monday or Tuesday of next week, but that could change very quickly. So we're meeting tomorrow. If we decide to have a quiz before break, you might have a quiz before break. But as of right now, it's not on the calendar. But I'll let you know. Yeah. No. All right. Jump down and do number 4. Try number 4 on your own. Lots of good things happening. Hopefully you did a T-chart for 242 and found 2 times 121. And then times, if you want to break it down to a square, that would be x to the 5th. And then y to the 6th is being squared to get y to the 12th. And so the square root of 121 comes out as 11. The square root of x to the 5th squared is going to be x to the 5th, but you need absolute value bars around that because it's an odd power. And then the square root of y to the 6th squared would be y to the 6th. That's an even power, so you don't need absolute value bars. And that leaves you with the square root of 2. Who got that right on their own? Good. What's different about number 2? Cube roots. So instead of looking for squares, we're going to be looking for cubes. What's the largest perfect cube factor of 54? 27. So we'll have the cube root of 27 times 2 times what could I cube to get y to the 9th? Y to the 3rd, good. So I broke it into a cube because we're taking the cube root. And then times what could I cube to get x to the 4th? Just x with how many left over? 1. So my cube root of 27 is going to come out as a what? 3. The cube root of y cubed is going to be y cubed. Do I need absolute value bars? No, because you can take the cube root of negative numbers. So you don't need absolute value bars here. And then the cube root of x cubed is just going to come out as an x. And what does that leave me with underneath? The cube root of 2x. Good. Questions on number 2? Try number 5. See if you can get it. Your largest perfect cube factor of 81. 27. So that'll be 27 times 3. And then I'm going to have y cubed times y squared. And then I'll have x to the what? 4th power cubed will give you x to the 12th. And so the cube root of 27 is 3. The cube root of y cubed is y. The cube root of x to the 4th cubed is x to the 4th. And that leaves me with the cube root of 3y squared. Who got that right? Good. What? because 3 is not a perfect cube. Questions on number 5? Good little review. We did this a little bit, I think, in Unit 3? Maybe Unit 3? But revisiting it. Number 3, we're doing fourth roots. At the top of our paper, let's write down some of our powers of 4. And so if I'm doing powers of 4, 1 to the 4th is 1. 2 to the 4th is 16. 3 to the 4th, so let's take this step by step. 3 times 3 is 9, times 3 again is 27, times 3 again is 81. 4 to the 4th is, 4 times 4 is 16, times 4 again is 64, then times 4 again, 256. What do you notice about 1, 16, 81, and 256? Yeah, they're all squares, aren't they? Isn't 1 squared? 16 is 4 squared. 81 is 9 squared. 256 is 16 squared. How could I get 16 from 4? 4 squared. So it's just 4 squared squared. 3 squared squared. 2 squared squared. 1 squared squared, right? So our powers of 4 are also perfect squares. Let's do 5 to the 4th. What's 5 squared? 25. Now square it again. Whoa. 25 squared. Not 15. That's 15. It's 625. So if you know your perfect squares, you can just square them again to get your fourths. And what do you notice about number 3? Yeah, 625. The fourth root of 625 is going to give us 5. So that's a perfect fourth root, I guess you would say. So we'll leave that alone. So we've got the fourth root of 625 times, what could I put to the 4th power to get x to the 6th? X to the, nope, just x. Times x to the 2, I think is what you were thinking about. And then times, what could I raise to the 4th power to get y to the 8th? Y to the 2nd, good. I am taking an even root, so if I take out an odd power, I'm going to need absolute value bars. The 4th root of 625 is 5. The 4th root of x to the 4th is the absolute value of x. I can't take the 4th root of x squared, so that's staying. The 4th root of y squared to the 4th is y squared. And that leaves me with the 4th root of x squared. Let's star this one. Ask me about that tomorrow, because there might be a different way we can write that. But ask me about that tomorrow. Ready to try number 6? Try number 6, see how it goes. You have the 4th powers at the top of your paper, hopefully, to help you. But try number 6, see how it goes. The largest 4th root factor of 48. 16 times 3. So this will be the 4th root of 16 times 3 times, that'll be x to the 3rd to the 4th. And then this will be y to the 4th to the 4th times y, yes? That'll give me y to the 4th is y to the 16th, so you have 1 left over. The 4th root of 16 is 2. The 4th root of x to the 3rd to the 4th is x to the 3rd. I need bars around that. And then the 4th root of y to the 4th is y to the 4th. And then I've got the 4th root of 3y. Who got that right on their own? Good. What questions do we have? On the 3rd page. All right, nothing. Oh, adding and subtracting. This is great. So adding and subtracting roots, you can only do this with like terms. So only with, and I'm going to call it like terms, but we'll explain what that means. Like terms, when it comes to radical expressions, means that it has to have the same kind of root. So you cannot add and subtract like a square root with a cube root. That doesn't work. And they have to have the same number underneath the square root. So you can't add and subtract the square root of 5 with the square root of 3. It doesn't work. You can only add or subtract the square root of 5 with the square root of 5. And so for number 7, it's nice if you can simplify it first and then try and add and subtract. So with number 7, can I simplify 3 square root of 5? No, the only factors of 5 are 1 and 5, and neither, well, 1 is a perfect square, but that won't help us. So 3 square root of 5 stays the same. What about the 6 square root of 45? Yeah, how? 5 and 9. Which one do you know the square root of? 9, which is 3. What is 6 doing with the square root? Multiplying. So when you pull that 3 out, it's going to multiply. So I'm going to show every step that you might need so nobody gets lost today. 3 square root of 5 minus 6 times 3 square root of 5. Some of you will be like, do I really have to show all those steps? No, but I'm going to show every step so that we don't lose people today. 3 square root of 5 minus 6 times 3 is 18 square root of 5. Now I have what I just called like terms. They're both square roots of 5. And it kind of works the same as if I gave you 3x minus 18x. How many x's do you have there? What? Negative 15x. The x didn't change when you added or subtracted those together. So here, the root is not going to change. It's just going to be negative 15 of them. So negative 15 square root of 5. Once you simplify your square root as much as you can, it shouldn't change for the rest of your problem. So we simplified it down to the square root of 5. The square root of 5 should not change for the rest of our problem. Questions on that one? Y'all want to try number 8? No? What's the largest perfect cube factor of 80? Factors of 80, go. Oh, it is 8. Good, you rescued us. It is 8. 8 times 10 times x, y. X and y, neither of those have a power of 3 on them, or even anywhere close, so we're not going to be able to take either of those out. Minus 8 times the cube root of 270's perfect cube factor is 27. 27 times 10 times xy. The cube root of 8 is 2. That's going to multiply with the 3 when I take it out. And I'll have the cube root of 10xy left. Minus 8 times, what's the cube root of 27? 3. And I'll have the cube root of 10xy after I take that cube root out. It's 3 times 2. 6 cube root of 10xy. And then I've got minus 24 cube root of 10xy. And how many cube roots of 10xy do I have? Close? Negative 18. Negative 18 cube root of 10xy. Now, a while back when this was on a quiz, I had to take points off because a lot of people forgot this little guy. Don't forget your index or your answer is wrong, because negative 18 square root of 10xy is not the same thing as negative 18 cube root of 10xy. So don't forget that little index there. What questions do we have? All right, working with fourth roots. Nope, cube roots still. What's the largest cube root factor of negative 3? Close. Negative 1. If I could take out the negative, I want to take it out. So negative 1 times 3 is good. Plus 2, and then cube root of 162. You can notice we did some long division in B block with 162 to try to figure out our factors. 1 and 162, 2 and 81, 3 and 54. It's not divisible by 4. Tell me why. Notice when we divided by 2, what did we get? An odd number. If you divide by 2 and get an even number, you can divide by 4. If you divide by 2 and get an odd number, you can't divide by 4. So, not divisible by 5. What about 6? 6 and 27, what do you know about 27? It's a cube. So, 6 times 27 here, plus 3 cube root of, what's the largest perfect cube of 81? 27 times 3. So for the first one, I've got the cube root of negative 1, which is negative 1. Negative 1 times itself 3 times, so negative 1 times negative 1 times negative 1 is negative 1, so it's still negative. And then I've got the cube root of 3 plus 2 times what? 3, because that cube root of 27 is 3, and then that's cube root of 6 plus 3 times 3, because the cube root of 27 is 3, and then you've got the cube root of 3. Some of this you might be able to do in your head, which is fine. I'm showing all the steps today because this is the first time we're seeing this, sort of. Negative 3 times negative 1 is 3, and then I've got the cube root of 3 plus 2 times 3 is 6. I've got the cube root of 6 plus 3 times 3 is 9, and I've got the cube root of 3. Which ones go together? The first and the last. So the middle one's going to stay the same. How much do I have if I have 3 cube root of 3 plus 9 cube root of 3? 12 cube root of 3 plus 6 cube root of 6. Notice, if you weren't paying attention and you thought the radicals added together to make 6, then you would have one more step to do, right? And that would be way off. So make sure once your radical is simplified, it doesn't change anymore, even when you add them together. The one exception is when we multiply. Haha. Flip it when you're ready. Is this the... Oh, this is the back. Good. I think multiplying is nicer. Dividing is nicer. I would simplify first, though, so that your numbers aren't so crazy, because I would rather find my perfect square factors of 12 and 75 than find my perfect square factors of whatever 12 times 75 is. So, perfect square factor of 12, what is it? 4 times 3, and I've got times, what's the perfect square factor of 75? 25 times 3, good. The square root of 4 is 2 square root of 3 times the square root of 25 is 5 square root of 3. Now the way that these work is your numbers that are on the outside are called coefficients. Those multiply together. So 2 times 5 is going to give me 10, and then the inside also multiplies together. So the square root of 3 times the square root of 3 multiplies together to give you the square root of 9. But what is the square root of 9? 3. So this is 10 times 3, which is 30. So your coefficients multiply, your radicals multiply underneath the radical, and then you see if you can simplify what you have left. Do what? So 11, same thing, but we're doing fourth roots. So what's the largest fourth root factor of 96? 16 times, close. 16 times 4 is 64. 6. Times, I've got 3y fourth root of, 245. 245 is kind of large, and it's kind of an odd number. It actually is an odd number, but anyways, kind of an odd number. We know 245 is divisible by what? 5. 5 times what gives you, how many times does 5 go into 24? 24. 4 times. What's 5 times 4? 20. So how many did that leave left over? 4. So then now we're trying to go into 45, right? How many times does 5 go into 45? 9. So it's 5 times 49. And 49 breaks into what? 7 and 7. 5's prime, 7's prime, 7's prime. This is called a prime factorization. If it's kind of a weird number, you could look at this. If we're taking the fourth root, we want a number that showed up 4 times. Do we have that? Between 5, 7, and 7? No. So this is not simplifiable. It's going to stay the fourth root of 245. But we know the fourth root for the first one of 16 is 2. That's going to come out and multiply 4x to make what? 8x. And then you'll have the fourth root of 6 times 3y, the fourth root of 245. Eight x and 3y are going to multiply together to give you what? 24xy. Good. And then our square roots are also going to, or our fourth roots are going to multiply. So we'll have the fourth root of whatever 245 times 6 is. 245 times 6. What's 5 times 6? 30. Carry the 3. What's 4 times 6? 24 plus 3. 27. Carry the 2. 2 times 6 is 12. Add the 2. 14. Now, didn't we break 245 down up earlier? Like up on the top? So, 1470, we just found out is 6 times 245, right? We already know 245 breaks down into 5 and 49, which breaks down into 7 and 7. So we have that prime factorization there. What two prime numbers multiply to give you 6? 2 and 3. Do I have any number 4 times? No, then this is where it stays. There is no fourth root there that I can take. Yes. Yes. Questions on number 11? I think that's probably the toughest one on this page, if I were guessing. If I have my memory correct. Sometimes it's nice to be able to simplify early, and then sometimes you want to wait. 12, you can do one of two ways. The first way is you could simplify the square root of 20. What's the square root of 20? The square root of 5 times 4, which one do you know the square root of? The square root of 4 is 2, so this is really square root of 5 over 2 square root of 5. How many square roots of 5 do you have on the top? 1. What's the square root of 5 divided by the square root of 5? 1, so that what does that leave us with? 1/2. You could also look at it kind of like number 14. So number 14, that essentially is written a different way than number 12, but they mean the same thing. And so if you wanted to write number 12 like number 14, you could have said the square root of 5 over 20, which is equivalent. And what does 5 over 20 simplify to? 1 over 4, and what's the square root of 1? 1, what's the square root of 4? 2. You could have gotten there that way as well. So there's two different ways to look at it. So if we're doing 14, which is very similar, what does 6 over 48 simplify to? 1 over 8, yep. So this will be the cube root of 1 over 8. What's the cube root of 1? 1. What's the cube root of 8? 2. Y'all want to try 13? Okay, go ahead and try it. The largest perfect cube of 16 was 8, and that's times 2 to get 16. Times the largest perfect cube of 54 is 27 times 2. The cube root of 8 is 2. That'll leave cube root of 2. Times the cube root of 27 is 3. That'll leave cube root of 2. Your 2 times 3 on the front multiply to give you 6. And then your cube roots also multiply to give you the cube root of 4. Who got that right on their own? Good. Questions on that? Now we're going to be doing something that you should have learned in geometry, I hope. If you didn't, there's always a time to learn it. Rationalizing the denominator. So we need to turn the denominator from an irrational number into a rational number. And we're pretty used to square roots at this point. How do I rationalize the denominator on number 15? No. Do what? Yeah. So I've got the square root of 30 on the bottom, which is irrational. How do I fix that? Yeah, multiply by the square root of 30 over the square root of 30. What am I really multiplying by? A 1, right? A well-chosen one, so that I don't change the quantity of this number, but I change the way that it looks. Your 7 and your 30 in the numerator are both underneath square roots. So they're going to multiply. What's 7 times 30? 210. So you've got the square root of 210 over, what's the square root of 30 times the square root of 30? Square root of 900, which is 30. That's why it works. Your 210 cannot divide by 30 here because 210 is in a square root and 30 is not. So that's the way that it stays. What about 16? Close. What could I do first that might make it easier on myself? Yeah, the square root of 12 is really the square root of 4 times 3, right? So I could say 5 over the square root of 4 times 3. Which one do I know the square root of? 4, which comes out as a 2. So this is going to come out. That's going to leave me with 5 over 2 square root of 3. The 2 is not the problem. The square root of 3 is the problem. So that's what I'm going to want to multiply by, is the square root of 3 over the square root of 3. 5 times the square root of 3 is just 5 square root of 3 in the numerator. The 2 is going to stay in the denominator, but what's the square root of 3 times the square root of 3? 3, and those two are going to multiply because the 2 was multiplying with the square root. What's 2 times 3? 6. So this is 5 square root of 3 over 6. If you simplify first, it saves you from simplifying bigger numbers later. It is, but what's the square root of 9? There you go. For number 17, I have the square root of x to the third on the top, and then the square root of 6xy on the bottom. Is there anything that I can simplify in either place? Numerator or denominator? Yeah, so on the top, this could be the square root of x squared times x, right? On the bottom, there's nothing I can simplify there. There's not a perfect square factor of 6 other than 1. There's not 2 x's or 2 y's, so that one doesn't get simplified. The square root of x squared is absolute value of x. And then we've got the square root of x over the square root of 6xy. The terrible part here is that the square root of 6xy is irrational, so we're going to have to rationalize it by multiplying by the square root of 6xy over the square root of 6xy. The absolute value of x stays on the top. You're going to multiply the square roots to be 6x squared y over what's the square root of 6xy times the square root of 6xy. It'd be the square root of that, right? If you're multiplying a square root times itself, then it's just going to be the square root squared. And what does the square root and the square do to each other? They undo each other, right? So this will be 6xy. We'll wait on absolute values at the end. Can I simplify anymore? Yeah, don't I know the square root of x squared? Yeah. Is there anything else that I can simplify? Do we have the same factor top and bottom? What? On the outside. Not in the square root, but on the outside of the square root. Don't you have an x and an x? So those make 1, right? We're still going to pull the square root of x squared out, so we're still going to have the absolute value of x on the top, the square root of 6y on the top, and then on the bottom will be 6y. Is there anything else we can simplify? No. Make me feel better, and let's put the absolute value on this. But I'm going to star this and ask me about it tomorrow, because I'm going to make sure that that goes there. We did, and then we got another one because of this. Yeah. Does that make sense? That's kind of why I wanted to get rid of it at that point, because I knew we were going to have another one come out. Yeah. Other questions on that? Is this the last one on this page? Yeah. Flip it when you're ready. This is the page where we're only going to do the evens, and then you'll have some time to work on your homework. We're going to work on the evens on this page because you'll have this on your homework 5.2 tonight, and I want you to be able to do it. So we're going to do evens here. For number 18, we've got 5 over the cube root of 3. Tell me why the cube root of 3 is irrational. Why is the cube root of 3 irrational? Yeah, 3 is not a perfect cube, so it is irrational. We want to turn the cube root of 3 into a rational number. What am I going to have to do to make the cube root of 3 into a rational number? So if I multiply by, let's just think about it on the bottom. If I multiply by the cube root of 3, what will that give me? The cube root of 9. Do we know the cube root of 9? No. So it doesn't work the same as square roots. We need a cube root that I know the cube root of. What number could I turn 3 into by multiplying that I know the cube root of? 27. What would I multiply 3 by to get 27? Close. 9, right? So then I'm going to multiply by the cube root of 9 over the cube root of 9 to multiply by a well-chosen 1. In the numerator, the 5 is your coefficient. The cube root of 9 goes behind it. And then on the bottom, cube root of 3 times the cube root of 9 is the cube root of 27. And the reason we did that is because the cube root of 27 is 3. Oh, quit. This will be 5 cube root of 9 over 3. Cube root of 9 could not be simplified. The 3 on the bottom is rational, so we're done. Also, you can't divide 5 and 3 by a common factor, so that means we're really done. So you have to be careful if you're doing square roots, cube roots, or fourth roots. You want to turn it into a root that you know, because that's how we get rational numbers. Let's skip to number 20 when you're ready. We're doing cube roots here too. So if I've got the cube root of 4 on the bottom, how could I turn that into a cube root that I know? Do what? Even lower than that. We don't have to turn it into 64. 16 is not a perfect cube. 8, yep. So we could turn it into the cube root of 8 by multiplying by the cube root of 2. Same as the last one, the numerator is going to be 5 times the cube root of 2 over the bottom is going to be the cube root of 4 times 2, which is the cube root of 8. And what is the cube root of 8? 2. So 5 cube root of 2 on the top over 2 on the bottom. You can't divide 2 and 2 here because the 2 in the numerator is in a cube root and the 2 in the denominator is not. No common factors between 5 and 2, so we're good here. What questions do we have? Am I going too fast? Number 22. Ooh, interesting. Is there anything I can simplify before I get started? No, we don't know the fourth root of any of these. They don't have fourth root factors. And so let's just go ahead and rationalize. To rationalize, we're going to have to multiply by something that will turn the fourth root into something I can take the fourth root of. So what would I multiply 2 by to get something I know the fourth root of? 8 to turn it into 16, right? So we'll multiply that 2 by an 8. What could I multiply x squared by to get a fourth root that I know? X to the what? 4? Even lower than that. If I wanted to get x to the 4th, I could multiply by x squared, right? So then same thing on the top. Fourth root of 8x squared. On the top, your 5 is underneath a fourth root, and so is your 8x squared. So you can multiply those together. So that'll be the fourth root of 40x squared. Over, on the bottom, we've got the fourth root of 2 times 8 is 16. And x squared times x squared is x to the 4th. 40 breaks into 5 and 8. And neither of those are perfect fourth roots. 8 doesn't break into any fourth roots. So the 40x squared is going to stay underneath a fourth root. So that's going to be fourth root of 40x squared. What's the fourth root of 16? 2. What's the fourth root of x to the 4th? Absolute value of x. And we're done there. Pretty good. So you'll have to rationalize denominators on tonight's homework 5.2, and then you'll also have to multiply binomials on your homework tonight. I think this is the last even on the page, right? Yeah. So if we're multiplying number 24, what do I multiply first? First and the first, 2 times 2 is 4. And then first and the last, what's 2 times negative square root of 2? Negative 2 square root of 2. And then middle, I've got square root of 2 times 2, which is positive 2 square root of 2. And then for the last one, I know a positive times a negative is going to give me a negative. What's the square root of 2 times the square root of 2? The square root of 4, which is 2. What do you notice? A lot of 2's. You can add the 4 and the negative 2 together. Can you add the 2 square root of 2 and negative 2 square root of 2? Yeah, what does it make? 0. And 4 minus 2 is 2. So we started with something that looked irrational, and it simplified down to something that's rational. Make sense? We'll get more practice with this tomorrow. You've got the rest of class, about 20 minutes, to do your homework or your Math Excel. Make sure to ask me questions if you have them.